Okay, this is the 2015 NCEA 2 exam. This is Algebra for Year 12. This is question 3c. So we're nearing the end of the exam. Just one more question after this to go. So it says, for what values of k does the graph of the function blah never touch the x-axis? Well, in order for it to not touch the x-axis, then it's going to have to be using a discriminant where the discriminant is going to be less than 0. So that's the basis under which we're going to proceed. So let's have a look and see how this is going to play out. Now, the writers of the exam have been kind enough to actually give us the values for A, B, C, the coefficients. So A is the coefficient of x squared, and the coefficient is going to be a 1. B is the coefficient of the x value, which is a 3k minus 1. And the C value, the coefficient of the x to the 0, is going to be 2k plus 10. All right. So now let's use the discriminant. Well, we know the discriminant, which is b squared minus 4ac, is going to be less than 0. So let's plonk all this in and see where we go. So b squared, so it's going to be 3k minus 1. I'm just going to write it twice because it's squared, yeah? 3k minus 1, because I'm going to just multiply it all out straight away. Minus 4 times a, well, a is 1, times c, and c is going to be, I'll put brackets around this, 2k plus 10. And all of that, of course, is less than 0. So let's expand all this out. We've got a 3k times 3k. That's going to be a 9k squared. Negative 1 times negative 1 is going to be a positive 1. And we've got a negative 3k and another negative 3k, which is going to be minus 6k plus the 1. Now, this is going to be 4 times 1, so that's going to be minus 4 times 2k plus 10. That's less than 0. All right. Let's expand this bit here out. So this is going to be negative 4 times 2k. That's going to be negative 8k. And negative 4 times 10 is going to be negative 40, less than 0. And this stuff just stays the same. 9k squared minus 6k plus 1. Now, let's see if we can simplify this. Just I think collecting some like terms. I've got a 1 minus 39. Well, that's going to minus 1 minus 40, which is going to be, negative 39. I'm getting ahead of myself again. I've got a negative 6k and a negative 8k. Well, it's going to be a negative 14k. And I'm left with a 9k squared. All right, so let's see if we can factorize it first, but I'm looking at this and I'm thinking probably we're going to have to use a quadratic formula, but we don't know. Let's have a look. So 9 times 39, let's just use the calculator for that, why don't we? So 9 lots of 39 is 351. So we're looking at 351, little sidebar here, 351. We're wanting factors of 351. Well, we know that 9 times 39 is 351, but we want them to add or subtract a 14. Now, 13 can also be, because this is 3 times 3, this you see, times, and this is going to be 3 lots of 13. So if we went 3 times 3 times 3, that's 27 times 13. Does 27 times 13 work? And look, it does, because 27 minus 13 is going to be 14. So suddenly we've got our 2 factors. Here they are. So we've got a 9k here and a 9k here. So we're going to factorize by division. So signs are different. Biggest is negative. Signs are different. Biggest is negative. So the biggest is going to be 27. The other one's going to be a 13. Can we divide anything out here? Yes, we can. We can divide all of this by 9. So I'm going to divide all of that by 9. And that's going to be k minus 3 times 9k plus 13. All right. So there really is the essence of what we need to do here. So let's solve for this, solve for k. So we can say either k is going to equal 3, or k is equal to negative 13 on 9. There it is. That's meant to be, say, negative 13, by the way, in case you're wondering. Because it doesn't really look like it, does it? It seems to be, the 1 seems to be crossed by the negative sign. All right, so there are our two critical values, 3 and negative 13 on 9. So if I was to draw this out, for example, it would look something like this. So here is some sort of a graph showing this. So we've got a 3 over here. So I'll put a 3 here. And k is negative 13 on 9. And by the way, negative 13 on 9, what does that come to? Negative 13 divided by 9 is 1.4 and change. So I'll put it here. So it's a negative 1.4 recurring. There it is. So the graph's going to go head down like this. It's going to turn around. It's going to come back up, head up through here. The axis here, of course, is my k-axis. And this, of course, is my f of k, or the function of k-axis. It's going to cross down here at negative 39. Negative 39, that's what's going to be down here, negative 39. Just for context, we don't have to draw this, of course, but it's important, I think, to understand how this all plays out. So this is going to be less than 0. So in other words, the values of k for which this would be true means that the values are going to have to fall between 3 and negative 13. So they're going to have to be values that are going to be inside here. Yeah, and the reason they're going to be here is because we're looking for k values that are less than 0. Well, here the k values, f of k values, the f of k's are greater than 0. Yeah, here the f of k's are less than 0. Greater than 0, of course, and we're looking at values that are going to be going up like this. But less than 0, the values are going to be way down here and are going to be inside here. Yes, they're going to be inside here like this. And they're going to be falling somewhere between here and here. So the values, if the f of k or the values here are less than 0, then they're going to fall between these two, because these values here are less than 0. If they were greater than 0, they're going to be up here, and the values are going to spread out here and be progressively wider and wider and wider as the parabola moves wider as it goes up. All right, so therefore it means that the values are going to fall, as I say, between these two. So therefore k, and we can actually, I suppose, draw this out. And on a number line, it's probably a useful way of doing it. So I've got negative 1.4 recurring. There it is. And there is my number line here. Here's my number line. And over here I've got a 3. And in the middle here I've got somewhere I've got a 0. Here's my 0. But the values are going to fall between here and here, not including those 2 points. So k is going to have to be less than 3, but greater than negative 1.4 recurring. I'd probably, to be honest, write that as an improper. I do like that better, but nothing entirely wrong with writing it like that if you really wanted. Anyway, they're the values of k which you would use that would make this equation here true. And that's how I would go ahead and solve that. So my solution is this at the bottom here, and that's how I would get there. Hope that makes sense.